Hello friends, welcome to my educational channel KJ Digital Classroom. Today we are going to discuss some interesting topics of mathematics. Before we start the video, don't forget to subscribe my channel and watch this video till the end, share the video and like the video. Leave the comment in comment box. Thank you and let's start. Up till now, you were studying the arithmetic in which you were mostly using arithmetic symbols 0, 1, 2, 3, 4, 5, 6, 8, 9. These arithmetic symbols are also known as the numerals. You were also using sign plus for addition, minus for subtraction, multiply for multiplication and division for division to arithmetic calculation. In this chapter or in this section we shall make a beginning of the study of a new branch of mathematics known as the algebra. Beside the arithmetic symbols and signs of the operation of addition, subtraction, multiplication, division, algebra also use letters from the various alphabets like English, Greek, etc. These letters are used either to generalize result or represent unknown quantities and are known as a letter symbols. So in this chapter we shall first study basic operation of addition, subtraction, multiplication and division on letter symbols. Friends, in arithmetic we have studied that 7 multiplied with 0 is equal to 0. Same way 12 multiplied 0, the answer will be 0, and 3 multiplied 0, answer will be 0, and so on. In another word, any number multiplied by 0 is 0. This statement can be rewritten briefly by using the letter as x into 0 is equal to 0. Here x represents any numbers. Thus, the arithmetical statement any number multiplied with 0 is equal to 0. Let's discuss some basic operation on the literals and numbers. So, we know that literals are used to represent the numbers. Therefore, literals and their combination with the numbers follow all the rules of addition, subtraction, multiplication and division of number as well. We shall now study this operation and their properties. Suppose we are asked to find the sum of two numbers, say 3 plus 5. So 3 and 5 is denoted by 3 plus 5. Same way, the sum of x and 7 is denoted by x plus 7. The sum of x and 3, we can write x plus 3. And if statement is like this, 3 more than a number x, so that we can write x plus 3. Now, if statement is written as like this, x added to 9, so we have to convert into literals as like this, x plus 9. Increase x by 4, it means x plus 4. Now see carefully, the sum of x and 5 added to y, you can see that the sum of x and 5 I put in the bracket, and the answer which is further added into y, so that x plus 5 into the bracket plus y. X added to the sum of y and 4, x plus y plus 4. Let's discuss some properties of addition of literals. Commutativity means for any two literals a and b, we can write a plus b or b plus a. The result are same, so that a plus b is equal to b plus a. In associativity, for any three literals a, b and c, we can write a plus b plus c, whereas a and b in the brackets. Or in other way, a plus into the bracket b plus c. And in identity, for any literals a, we can write a plus 0 is equal to a, 0 plus a is equal to a. Here 0 is known as the additive identity. Subtraction of literals. If we ask to subtract 5 from 7, then we write 7 minus 5. Exactly in the same way, when we are asked to subtract a number 3 from a literal a, so it denoted by a minus 3. 5 less than a literal x, we can write that x minus 5, and decrease x by 7, so that we denoted as x minus 7, and subtract 4 from x, so we can write x minus 4, and x less than the sum of y and 7, so that we can write as like this, into the bracket y plus 7 minus x, and decrease the sum of x and y by z, so that into the bracket x plus y minus z, because the sum of x and y decreased by z, so that into the bracket x plus y minus z, and a is less than 4, it means 4 minus a. It should be noted that commutativity and associativity of the subtraction are not true for literals, as they are not true for numbers. Let's discuss about the multiplication of literals. In arithmetic, we studied multiplication as the repeated addition. For example, 3 plus 3 plus 3 plus 3, it means 4 times 3 is written as 4 multiplied by 3. Same way, if a plus a plus a plus a, it means 4 times a, and if for literal x, x plus x plus x plus x is equal to 4 multiplied by x, so we can write 4x. It should be noted that the product of the type a multiply sign and 4 is not written as a4. For conventionally we write as 4a. Properties of multiplication of literals. First, commutativity. For any two literals a and b, we have a into b is equal to b into a. Associativity. For any three literals a, b and c, we have into the bracket ab into c equal to a into the bracket b into c. In identity, for any literals a, we have a into 1 is equal to a, and 1 into a is equal to a as well. Here 1 is known as the multiplication identity. For example, 5 times x, it means 5x, and the product of 7 and x, we can write 7x. And if statement is like this, multiply x by 17, so that we can write 17x. In arithmetic, we studied that the division sign is read as by between the two numbers, means that the number on the left of the division sign is to be divided by the number on right. For example, 18 divided by 3 means that the number 18 on the left of the division is signed to be divided by the number 3 on the right of the division sign. In this case of literal numbers also, a divided by b, and so that we can written as a upon b. For example, 20 divided by x is denoted as 20 upon x, and x divided by 3, it means x upon 3, and x divided by 5, so that we can write that x upon 5. We shall now illustrate the 4 basic operations of addition, subtraction, multiplication and division by following examples. Now see the example. Now see this statement 2. 3 times x added to 7 times y, it means 3x the product of 3 and x and product of 7 and y, add the both, so we can write this 3x plus 7y. Quotient of x by 4 is added to y, it means x upon 4 plus y. In arithmetic, we studied that repeated product of a number with itself is written in the exponential form. For example, we have written 3 into 3 as 3 power 2. Same way, 3 into 3 into 3 is 3 raised to 3. Since a literal number represents a number, therefore the shorthand way of writing of the repeated product of a number with itself in exponential form is also applicable to literals. Thus, if a is literal, then we write a into a as a square or a raised to the exponent 2 or a raised to power 2 or a square simply. Same way, a into a, we can write that a cube. Same way, a into a into a into a into a is a raised to 5 and so on. We can also write as like this, 7 into a into a into a into a is 7 into a raised to 4, or we can say that 7 into a exponent 4. 4 into a into a into a into b is 4 into a raised to the exponent 3 and b raised to the exponent 2, or simply 4 a cube b square, and 3 into a into a into b into b into b into c into c into c we can write as 3 into a raised to 3, b raised to 3 and c raised to 3 as well. We read a square as the second power of 2 or square of a, or a raised to the exponent 2 or a raised to power 2 or a square. Now let's try to write each of the following in exponential form. Example 1, a raised to 2 into b raised to 3 multiply with a raised to 3 into b. Now a raised to 2 into b raised to 3, it means a 2 times in multiplication and b 3 times in multiplication. Same way, a 3 times in multiplication and b 1 time in multiplication. Now we write all this together as like this, a into a into b into b into b for a square b cube, and for a cube b, a into a into a into b. Now put all the literal a together, a into a into a into a into a and b into b into b into b, so that a raised to 5 into b raised to 4. Example number 2, 3 a raised to 2 b raised to 3 into 2 a b raised to 4. So 3 a raised to 2 into b raised to 3 can written as 3 into a into a into b into b into b, and 2 a into b raised to 4 as 2 into a into b into b into b into b. Now write all the numbers and literals together as like this, 3 into 2 into a into a into a into b into b into b into b into b into b into b. It means 3 2s are 6, a 3 times, so that we can write a raised to 3, and b 7 times, so that b raised to 7. So final answer is 6 a raised to 3 b raised to 7.